Hey everyone, and welcome to this explainer. Today, we are popping the hood on a piece of technology that is quite literally powering the modern web. We're going to be demystifying React to see exactly how it works and why it's so fundamentally changed the way developers build web applications.
So what makes React the undisputed heavyweight champion of front-end development? It's a massive title, I know, but considering its massive adoption, it has absolutely earned it. Whether you're scrolling through a social media feed, executing a complex trade on a financial dashboard, or managing a high-traffic e-commerce cart, there is a very, very high probability that React is running the show behind the scenes. But how did it achieve this crazy level of dominance over traditional development methods? Well, to answer that, we need to break down its architecture piece by piece.
To figure that out, here is our roadmap for today. We'll start with the React revolution, followed by the power of component design. Then we'll explore the virtual DOM advantage, writing code in JSX, the vast React ecosystem, and finally look at how React is moving beyond the web browser.
All right, let's jump right into part 1, the React revolution. At its core, React is a JavaScript library originally developed by Facebook, specifically engineered for building dynamic and highly interactive user interfaces. And the origin story here is actually super fascinating from an engineering perspective. Back in the early 2010s, Facebook's legacy architecture, which leaned really heavily on traditional model view controller patterns, was completely failing them. They had this massive, complex application with constantly changing data. Notifications, messages, and feed updates were all just firing simultaneously. Using traditional methods meant every tiny data change triggered these cascading, super expensive updates to the document object model, or DOM. It caused massive performance bottlenecks and glitchy UIs. So React was born out of absolute necessity. They literally had to invent it to handle all this dynamic data efficiently and separate the complex UI from the underlying business logic.
Moving right along to part 2, the power of component design.
React's whole philosophy boils down to a few key benefits: reusability, modularity, scalability, and isolation. You can kind of think of components like Lego blocks, but with a highly sophisticated internal brain. Instead of building this monolithic, tangled web page, you construct totally isolated pieces: a search bar over here, a navigation menu there, maybe a specific button. And what makes this a total game changer for huge enterprise apps is how these components handle data through state and props. State lets a component manage its own internal data, totally isolated from the rest of the app. Props allow data to flow predictably down the tree. This strict isolation means no unintended side effects. If a developer tweaks the code in the search bar component, they don't have to sweat accidentally breaking the checkout cart. That modularity is exactly how engineering teams scale massive apps so seamlessly.
Okay, part 3, the virtual DOM advantage. So what is the virtual DOM? Basically, it's an in-memory representation of the real DOM that allows React to efficiently manage updates without manipulating the entire page for every single change. To really grasp why this is such a big deal, you have to realize that touching the real DOM is computationally exhausting. Every single time you touch it, you're forcing the browser to recalculate CSS styles, figure out layouts, and literally repaint the screen. Doing this constantly causes apps to stutter and lag. So the virtual DOM steps in like a high-speed drafting board. React calculates all the necessary edits and finalizes the structure entirely in memory on this lightweight drafting board first. It totally bypasses those expensive browser calculations until it finds the absolute optimal path.
Here is how this actually plays out step by step. First, a component state changes. Maybe you click something or new data arrived from a server. Second, React instantly spins up a brand new virtual DOM tree representing what the UI should look like now. Third, and honestly, this is where the magic happens. It compares this new tree with the old one. We call this reconciliation. React uses this highly optimized diffing algorithm to analyze both trees and figure out the absolute minimal number of changes needed. Finally, step 4, it batches those specific updates to the real DOM. By grouping all those operations into one single lightning-fast execution, React avoids triggering a bunch of repaints, giving you that buttery smooth user experience.
Which brings us to part 4, writing code in JSX.
JSX is a syntax extension that lets developers write intuitive, HTML-like code directly within their JavaScript. See, traditionally, developers were taught to strictly separate things. Keep your HTML structure over here and your JavaScript logic in a totally different file over there. React intentionally breaks that rule. They argue that rendering logic and UI logic are actually inherently connected. Now keep in mind, browsers can't just naturally read JSX. Before it ever reaches you, this HTML-like syntax is transpiled by tools like Babel into standard JavaScript functions, specifically calls to the React.ElementCreate API. So you really get the best of both worlds here. You get the visual ease of writing HTML markup combined with the sheer computational muscle of JavaScript to map over arrays, handle conditionals, and even catch syntax errors before the code ever runs.
Now let's zoom out a bit for Part 5, the vast React ecosystem.
So, React is incredible at handling the UI for sure, but complex enterprise applications quickly run into bigger architectural headaches. Like passing data through dozens of nested components can become a total nightmare, a problem developers call prop drilling. And that is exactly why the community build tools like Redux, which acts as a centralized store for application state management. Need to handle complex routing without full-page reloads? React Router facilitates navigation between views seamlessly. If you're spinning up a new project, Create React App handles all the heavy lifting of build configurations with sensible defaults. And for really robust production-ready architectures, frameworks like Next.js give you sophisticated solutions for server-rendered apps and API routes. The ecosystem literally fills every conceivable gap.
But these incredible tools don't just magically appear out of nowhere. This entire ecosystem is backed by a massively vibrant open-source community. You have brilliant engineers all over the planet constantly contributing to the core code, writing extensive documentation, and actively debating architectures on GitHub and Stack Overflow. This decentralized, community-driven approach is the real secret sauce. It's why React stays innovative and secure. When a team chooses React, they aren't just downloading some JavaScript library. They are plugging into a global support network that is constantly pushing the boundaries of what web apps can actually do.
And finally, Part 6, Beyond the Web Browser.
Historically, JavaScript applications had a massive hurdle when it came to SEO. Web crawlers really struggled to index dynamic content that hadn't loaded yet. But React's ecosystem adapted to this brilliantly with server-side rendering, or SSR, and static site generation, SSG. Using a framework like Next.js, the server can now process the React code and deliver a fully rendered, super lightweight HTML document right to the client. This means search engines can instantly crawl the page and the user sees the content immediately. But it doesn't stay static. Once that HTML loads, React does this thing called hydration, seamlessly attaching event listeners and transforming that static page back into a fully interactive dynamic web app in the background. It's pretty wild.
The underlying architecture of React is so remarkably robust that it has fundamentally transcended the web browser altogether. While React for the web targets the browser's DOM, React Native allows developers to build cross-platform mobile apps for iOS and Android using the exact same declarative principles. And this is crucial. React Native doesn't just render some clunky web view inside a mobile wrapper. It actually bridges your JavaScript code to interface directly with native UI components. A button in React Native compiles down to a real native iOS button or Android widget. This means engineering teams can maintain a highly consistent code base, share complex business logic, and still deliver true native performance across both desktop and mobile at the same time.
We've seen how React's component-based architecture enforces modular, scalable design. We've seen how the diffing algorithm inside the virtual DOM unlocks just incredible performance, and how its ecosystem stretches from the web all the way to native mobile apps. It really represents a fundamental shift in how we think about user interfaces. So, I'll leave you with this to consider. With its unmatched performance and component-based architecture, what new digital frontiers will React conquer next? As the demands of the digital landscape continue to grow, the foundational ideas behind React will undoubtedly be right there, driving the next evolution of technology. Thanks for hanging out with me for this explainer. Catch you next time.